In between 5 years ago and now, we had this massive thing called the merge that also changed the requirements fundamentally, and we didn't really touch it.
Well, if you're trying to be a staker, or if you want to run a full node, you want to know what hardware you need to buy, and you want to know that the hardware that you've bought can actually run the Ethereum chain.
If you're wanting to build your own blocks, although there is some enshrined proposability separation mechanism, then the hardware requirements might just increase. And I think this is the root here of the contention.
This is the EIP that sets what a requirement is for a node. And these are the type of nodes that would require to do the transition. And this is the speed we can achieve.
Welcome back to PEEPanEIP, the podcast where we explore Ethereum improvement proposals and break down what's ahead of Ethereum ecosystem. This is episode 145 brought to you by ECH Institute. Today, we are diving into EIP-7870 hardware and bandwidth recommendations, an informational proposal documented on January 26, 2025, co-authored by multiple developers and researchers. The proposal is currently in draft status. EIP-7870 outlines system recommendation for validators and full nodes, helping to ensure network efficiency and decentralization. To help us understand this proposed standard, we are joined by some incredible guests today. Kev Introduction, a key contributor to Ethereum client development, Parithosh Introduction, well known for his work on Ethereum testnet and validator monitoring, and Toni Intoduction, a researcher focused on Ethereum infrastructure and network optimization. Welcome you all to PEEPanEIP.
Hey, thanks for having us.
Hello.
Hey.
If you have been following PEEPanEIP, you know Pari and Toni have been keeping us updated on Ethereum research and network upgrades. They know the drill, but today we are also joined by Kev, and we would love to hear about his journey as a developer in Ethereum. Let's start with Kev introduction, followed by Pari and Toni.
Yeah, hello. Thanks for having me. I've been in the Ethereum ecosystem now, or the EF, for about 4 or 5 years. Before this, I was developing a compiler called Noir, which is for ZK circuits. Nowadays, I do mostly software engineering, mostly cryptography, and I'm currently the team lead for the ARG.
I can continue. Hey, I'm Pari. I'm part of the ETH Panda Ops team at the Ethereum Foundation. We do a lot of work around testing, validators, deployments of testnets and devnets to basically help find bugs before they hit mainnet.
Hey, I'm Toni. I've got involved with this EIP during work on analyzing the gas limit increase or analyzing blob throughput increase. And just as a little background, I work at the Ethereum Foundation at the Applied Research Group and have been very involved with everything around gas limits, block sizes. There was an earlier episode on EIP-7623, another one on the blob increase. So I'm very interested when it comes to those topics.
This is awesome. Yeah, I understand. This is like very interesting combination of many field getting together in one proposal, because this is a spec recommendation for running Ethereum node. Kev, I find it a little unfair. You have been with Ethereum Foundation for 4 or 5 years, and this is the first time we are having you. I hope to have you more frequent to share what's going on in Ethereum ecosystem. But this is great indeed that we are here to discuss this EIP. I believe that this is a very good way of learning about our developers, and then we'll get into what they are proposing. I understand this proposal talks a lot about specification, bandwidth recommendations, and so on and so forth. And community are eager to understand how they can participate in solo staking or becoming a home staker. So without further ado, let's get into the overview of the proposal.
I guess the first part would be the motivation as to why do we even sort of need these hardware recommendations. If you've sort of been in the Ethereum ecosystem as of late, people are talking about sort of increasing the gas limit, all of these sort of scaling techniques. And in order to know whether we can do any of these things, we sort of need to know what hardware these things are running on. The other sort of reason why you need something like this is well, if you're trying to be a staker or if you want to run a full node, you want to know like what hardware you need to buy. And you want to know that the hardware that you've bought can actually run the Ethereum chain. So for protocol developers, they should be using these hardware recommendations in order to run benchmarks so that when you buy hardware that is specified here, we've actually tested against it.
Also over the last years, we had some sort of recommendations when the beacon chain launched, but there hasn't really been an updating of these recommendations over the last years. There's been like some informal changes offered by ETHStaker or other organizations, but nothing that try to define what can run an Ethereum node. And I mean, in between 5 years ago and now, we had this massive thing called the merge that also changed the requirements fundamentally, and we didn't really touch it. So it feels like for a few years, it's just kind of implicit understanding of what the requirement is for a node, but that's very hard to design on. And same for the testing world. So we just spin up servers based on what we think should be either cheap or what we think should be what majority of stakers have. But that still is not the way to go. I think the idea of this EIP is to try and more strongly define these are recommendations of what you could run at. And then we can use that on the testing side. The researchers can use that as an understanding of what to design the protocol for, and stakers can use that as an idea of what to buy for. But one thing I do want to mention is that these are still recommendations. And I think there's also a lot of discussions about like, is this minimal or is this recommended? Probably the easiest way is if you go to Steam and you look at like, what do you need to run a game? There's always like required and minimal. So Ethereum probably will run on a node that has less specifications than what the document specifies. I, for one, still run a machine from 5-ish, 6 years ago now that I bought for not that much money, and it still doesn't consume that many resources. So the chances that we're going to bump up values that my machine can't run are in the next year are quite low. But at the same time, I think it's good to have like a target for the future. The idea is that if you buy a machine today, you shouldn't buy one that is comparable to mine from 6 years ago. You should probably buy one that will last you the next 5 years. And I think this document tries to clarify some of those things.
Right. I think it's a good point on the minimal. So for minimal, we did think about it for a bit, but this is actually quite a non-trivial thing to define, especially now that we have multiple clients, and the minimal requirements would likely change per hard fork, maybe even per client update. So just moving on to sort of the two types of nodes that you might want to run. So the first one is a full node, and this is basically a node that just follows the chain like usual. And the second one is a validator. So you pay 32 ETH and then you can become a validator. And the validator has two duties, you can say. One of them is attesting to blocks, and the other is actually building blocks or proposing blocks. We spent a lot of time on the local block building part. If you look at the table, the part that has the highest requirements are local block building. So if we look here, basically all of the nodes have 4 terabytes storage, and this is just mainly because all of the nodes are still storing history. You can likely run it with 2 terabytes, but it's definitely not recommended. If we can get 4 by the end of the year, then I imagine these hardware requirements would go down to 2 terabytes. If we look at memory, for example, as well, the full node has 32 gigabytes, and this is mainly because you can run these on 32 gigabytes. The reason we've sort of pushed it to 64 gigabytes is there is this other sort of project called the Beam Chain, and we've done some benchmarks, and we noted that if you try to switch to post-quantum, the memory requirements do increase by quite a lot. So this just gives us sufficient headroom. The number of cores and threads that we've chosen, 8 and 16, is quite sort of standard nowadays. The reason why we chose 4 and 8 for a full node is because you can do 4 and 8 as a full node. And the Parsmark CPU rating, if you don't know what a Parsmark CPU rating is, you can just think of it as a number that's used to sort of characterize the performance of your CPU. So just saying 8 cores is not enough to let people know how powerful their CPU needs to be. And then we get to sort of the most contentious part of this document, which is the bandwidth, download and upload speed. So as you can see, for a local block builder, we've set 100 download and 50 upload. And this is the reason why this is so high is because the local block builder needs to propagate the block within a very short amount of time. Currently, we've sort of informally just said 2 seconds. And the worst case block, let's just say 2 megabytes to send it to 8 people within 2 seconds, you need quite a lot of bandwidth. For the attester, it's 50/25, and for the full node, it's 50/15. The 15 megabits per second was because Pari's team did some benchmarks, and they figured out that I think it was around 12 megabits per second is sort of the upload speed that you can have, and the network wouldn't break. One thing to note here is that the full node specifications are sort of the closest to minimal you can get. And this is because there's this notion that you should be able to run a full node at home. So we sort of haven't pushed up the requirements for a full node as much as we could for like a tester and local block builder, just because we know that with attesters and local block builders / validators, they're already paying 100K. So they can sort of afford to have these more higher specs requirements.
I think one thing to also just add to the upload topic, if any of the listeners have listened to the previous one on blob increase, so there were a round of tests done in November where we did the non-finality test. And essentially, once you had non-finality, in order to recover, you need some amount of like base bandwidth, because every node is trying to like sync up whatever it has missed, as well as upload whatever it has to other nodes so that they can sync up. And what we tried was having a flat network. Basically, every node on the network just has something like 10 Mbps. And that network sort of breaks, even on regular operation, let alone under non-finality. So around like 12-ish Mbps is what we estimated as for a flat network, what is required. Of course, Ethereum is not a flat network. You have some people who have really fast internet, some people in the data center, some people at home, and so on. So kind of a naive estimation is roughly like 15 Mbps, such that even if every node on the network has this, we'll be fine. But yeah, there's a lot more complexity trying to achieve the bandwidth number. And that's also why I think Kev mentioned, or that's one of the reasons Kev mentioned, that internet is sort of a tricky one to try and give a recommendation on. Also because it's not that easy to change.
Right. Yes, I think this is where we spent most of our time sort of trying to get this EIP pushed through. And yeah, just as Pari said, you can't sort of buy yourself better internet after some sort of limit, and it depends on the infrastructure or sort of where you're located. So this is most of the important parts of the EIP, to be honest. The rest of it is mostly there if you want to get into the particular details of like what sort of storage do you need, what sort of hard drive do you need.
Yeah, maybe to add, because you already mentioned that bandwidth was the most contentious point. This kind of opens this box of what do we do with local builders in the future in general, right? Because do we always want to have people with low hardware requirements being able to build their own blocks, or are we fine as soon as we have some censorship resistance mechanism in place? Are we fine to kind of push people over to using PBS? Do we need some enshrined version of PBS to do so? Because we also don't want to rely on relays being able to censor the network. So this whole topic around local block builders is currently, I think, something that the community discovers as worth getting into the discussions and sharing their opinions. I think it's a very important topic. And currently, as we already can see on the slide here on the EIP, we are already kind of distinguishing and differentiating here between attesters and local builders, because we can assume that most validators are using MathBoost, but it makes it very clear that in the future, if you want to still build your own blocks, and not talking about the fallback from MathBoost if there is a liveness issue, but really if you're wanting to build your own blocks, although there is some enshrined proposal builder separation mechanism, then the hardware requirements might just increase. And I think this is the root here of the contention.
Right. I think right now you're sort of in a position where if you don't have sort of sufficient hardware, you can just build a block that's not that great. this is not sort of how I see it in the future, because once we add stuff like ZK proving, where you actually need to prove like the block that you've built, there is sort of a minimum amount of hardware that you definitely do need. Like maybe you can forego your 8 cores in that the document says and just build an empty block. But if you need to ZK prove, there's this minimum floor that gets added. And this is also sort of added with Fossil as well. Because if Fossil enforces that you need to add in, let's say, 16 transactions, then you have no choice in the matter.
Right, yeah. And the same applies basically also to state. So I think it's very interesting, especially this EIP, because we could probably do an episode on this EIP every year, because something might change every year as soon as we roll out statelessness, or as soon as we do CK EVMs, as soon as the gas limit increases, the blob throughput increases, peer does, and so on. So yeah, it's a very interesting one, let's put it that way.
Right. Yeah, I think there's still sort of conversations about whether we should have this as a live EIP versus whether we should push out a new EIP whenever things change. So you can imagine 4.4 is coming out end of the year and we need to modify this. So it's either, I have a preference for a live EIP just because I think if we keep making changes, tracking all of the EIPs or like figuring out what is the latest one, it becomes a bit of a headache.
Sure. I mean, I truly believe that this is one of a kind proposal. We have not seen so many EIPs in informational category, and this proposal is adding value as an informational proposal. That's what I feel. But I still would like to get into some follow-up questions, if that's okay. So first of all, thank you for this overview, Kev and Pari and Toni, adding some more context. I know this proposal is touching so many proposals. You mentioned about Fossil, blob throughput, increased call data, and so many proposals. So it's very important to understand like the need for having this proposal. Although Pari gave some context when we started talking about the specification of hardware, it was at the time of launch of Beacon chain, which was approximately 5 years ago. So that's like pretty long time that we had been done. But historically, general recommendation for hardware and bandwidths are part of specs repo. So this is one question that is always there in my mind. Like, why do we need to document is an EIP? What do you think is the main motivation to propose this as a proposal rather than keeping it as a form of specs repo?
Yeah, I think the initial idea was that if it's an EIP, it's extremely visible. And the second one is it becomes part of the space that you can reference in other EIPs. I can give you an example. When we were talking about Verkle and Verkle transition, the question was how fast can the transition happen? And this is a problem irrespective of what stateless approach we choose. The question still remains, how do we transition the tree, right? So now, if I tell you that you can use 1000 leaves, that has a certain computing overhead, RAM overhead, etc. I can do the transition 10x faster if I do 10,000 leaves. But the question comes in, what's the hardware required to support option 1 and option 2? And without a definition for what hardware a node is supposed to run, that becomes a very hard guesstimation. So in the future, if we have this as an informational EIP, we can say these were the values chosen because this is the EIP that sets what a requirement is for a node. And these are the type of nodes that would require to do the transition. And this is the speed we can achieve. So it kind of closes the loop a bit more. And same for Fossil and a lot of other EIPs, right? You can reference it in a way that you wouldn't be able to if it was a random specification on consensus specs, or if it's like an ETH Magician's post. It can live in any of those locations, but I think having it as an informational EIP makes it a bit tighter integrated to where it's useful.
Yeah, I think initially I was sort of saying, why does this need to be an EIP? And after a while, I sort of realized that there needs to be some point at which we say we have rough consensus on this, and the EIP process was sort of a good shelling point here.
That is good to hear. I'm gonna get back to you and talk more about EIP process and about your experiences. But before that, let's get over with the specs and other questions which are there. So, and It suggests that the proposal is a general recommendation, and you also mentioned in your overview that this is a general recommendation, and perhaps even with lower specification, things will run. I was following the comments on Fellowship of Ethereum Magician, which is generally a good placeholder for any kind of discussion with respect to any EIP. There was a suggestion from Nexo, who is one of the contributor of each staker community. So she mentioned about rather publishing this as an EIP with simple external links, we can perhaps publish a target time to profit. And this could be then externally linked to any actively maintained list that has specs and examples of hardware that currently fits that requirement. I'm curious to hear your thought on this. Like, do you believe that adding external links and keeping it somewhere else would add more value? Although you partially answered the question, just wanted to cement on the idea.
I think having it as an EIP in retrospect is probably the best way. I think we just need the sort of the confirmation that we've agreed as a, maybe not everyone agrees with it, but we have this rough consensus on this document. If I was to publish it at, let's say, some other website, then I don't think it would have the same sort of confirmation that I would like.
That makes a lot of sense, yeah. Okay, let's move on to the next topic, which is like one of the most contentious topic you mentioned about the upload speed. So the EIP specification, although Parithosh mentioned that why we are going with 12 Mbps and the number 12 for the general node running. And then there are different specifications added there in the proposal. Yeah, the biggest one, the highest one here is about local block building. As you guys mentioned that you guys have spent a lot of time in local block builder part. It is like most contentious and people want to understand because that's where people can make profit. It is mentioned in the proposal that if a builder cannot meet the speed, they risk slower propagation and causing late block. But again, going back to the comment which was there in the FEM, it suggests that generally speaking, it has been noted that the validated peak usage is viable than like 10 Mbps upload speed only. And we are giving 50 Mbps. This is like more than 5 times. I mean, 5 times plus, because if we are considering less than 10 Mbps. Is it an arbitrary number, or were there any research or any kind of benchmarking happening in the background for this recommendation?
Maybe I can give some context before we get into the question. So the problem here with local block builders is basically they have to get their block out themselves, right? MevBoost users can rely on the relay. They get the header from the relay. They sign the header of the block, which is a very small object. And then the relay helps them in propagation. So even though if you have a very weak internet connection, for example, you have 10 megabits upload, and you're still using MevBoost, then everything will work fine, very likely, because the relay will take over the propagation part and everything will work very smoothly. The problem is more if you're a local builder, then you might run into troubles when you try to get a very big block at the beginning of the slot, and then it needs to propagate through the whole network. And this is not something very new. So we saw local builders being outperformed by MevBoost builders basically since the merge. So already since the merge, we saw local builders being reorged more often, local builders missing more attestations, testing to the wrong head of the chain. So local builders have always been those that performed the worst. The unfortunate part here is that local builders are also a big, to solo stakers, right? To home stakers. So oftentimes local builders are also those that are actually running their nodes from their basement and not from some AWS instance. So we shouldn't confuse local builders with solo stakers because it's two different sets, but many people are basically in both sets. And as soon as we have some fallback for using MevBoost trustlessly, I think we can relax a bit on local block building and reconsider for what we actually need local block building at that point.
And maybe a bit more to follow up on concrete numbers, right, and positioning. I would say out of node runners on Ethereum, I have relatively good monitoring and a nice setup. So I have a node running at home, and on average, the node I have is at about 4.5 MB per second. And there are 2 peaks today at 10 MB per second. Even now, while I'm having this video call on Zoom, my home internet has not peaked above 10 MB per second. Right? This is quite easy and still well within the requirements. But I do think if we were to canonicalize today's requirements, that doesn't adequately address the needs of the protocol tomorrow. So if this document was to say, you can recommended hardware, recommended network usage is 4 MB per second. This is great because that means I don't have to do anything if I have a 4 Mbps connection. But what happens if we increase the block size to 60 million gas? Or what happens if we increase the number of blobs, which will happen with Spectra anyway, right? So you do always want to have a bit of headroom. And the target of the document will always be the average naive case. But if you're, for example, someone who's a bit more performance oriented, you could probably play with your minimum number of peers used. You can mess with a lot of different layers to get the usage down if that is what you care for. But again, the document is always at the average case. So the average case would say we have roughly a 3-ish X headroom for scaling the protocol with the needs. And you might also notice that earlier I had said that the flat network was taking about 12 Mbps. Then suddenly I'm saying 3 Mbps. Why is the difference? That again plays into what Toni was saying. We don't have a flat network on Ethereum. There are these sophisticated entities with block builders. There are gigabit nodes that basically are making it easier for me to run a node at home in some ways. So that's why the numbers are also a bit all over the place. But again, we would design for the average case. And ideally, the network performs better than the average case, but that is still what you design for.
Yeah, and maybe to add to that, because you've already mentioned right now that we have ways how maybe local builders can already limit themselves in what they are doing when building a block. There is, for example, the max blobs flag that some clients have already implemented. I think most clients want to implement it, which basically is a flag that you as a validator you can set. If you're still locally building blocks, then it will not include more blobs to your block than set in that flag. And this kind of allows proposers to still do local block building, but not risking, let's say, under PEERDAS building a block with, 2-digit number of blobs, and then risking being reorged because the block would very likely be out there very late. So there are those constraints. Of course, local block builders can always build small blocks, right? As long as they have access to state and everything, local block builders could always build a very small block, don't include any call data, make sure the block is able to propagate as fast as possible. But in the long run, of course, this can't be the goal here, because this creates situations that we already observed today where local block builders are not even able to fill the block up to the EIP 1559 target. So currently 80 million gas. So local block builders are basically at 7 million gas or something on average. So they don't even fill the block up to the limit. And this is very likely because the public mempool is just decreasing in size. And in the long run, we might see local block builders being more on the side of taking over completely new responsibilities, for example, being includers, making sure the network stays censorship resistant, and that kind of roles. And I would guess that's just my personal opinion that local block building might not be as important as guaranteeing censorship resistance through inclusion lists or something similar.
One thing I do want to push back on though is I think local block building is still different from full nodes. And I do want to clarify that even if, for example, Toni says local block building is not that important, it will continue to be important to be able to sync a full node locally and keep up with the chain and so on, right?
Yeah, I totally agree with that. Yeah. I think the requirements are also different because for full nodes, right, we kind of accept that they can fall out of sync if they're able to catch up. Of course, this is the most important thing here, right? Should always be able to sync the network, right? Super important. I definitely agree. Yeah.
I guess to answer Pooja's original question, so the 50 megabytes per second, basically, when we was at the drawing board, it was like, how do we figure out a number for this? And the natural number that we came about was just to look at what the global internet average is, just because local block builders, they should have basically what the average is. We also looked at sort of what is the worst case block that you can push through the network and like roughly how much megabits per second do you need for that. And we saw that it was roughly around the average number that we came up with. So like if you have a 2 megabyte block and you need to send to like 8 people, then that's like 16 megabytes of data. And if you need to send that within like 2 seconds, this is 8 megabytes. So you roughly need 64 megabits per second upload. So yeah, this is roughly where the number 50 came from. If you look at
Maybe a bit
statistical.
more on people who tried estimating more. So there was one approach where you tried using peers you're connected to and trying to estimate what bandwidth they have based on how fast you can pull data from them. So there have been some other approaches, but I think with every approach we tried, there was a different blocker, which is why a more naive approach of, yeah, this is the average speed, this is what we want to design for, was the desired way to go. Also, for example, if I have a Geth node at home, I'll say Geth Prism, I don't want Geth Prism to take 100% of my available bandwidth, because then I cannot be having this video call if you want a home staker, right? So you do want to set sort of sane upper limits. And this is also something that Geth and Prism need to sort of know themselves. If there's 50 Mbps, Geth cannot assume that it has the entire 50 Mbps, neither can Prism. So they also need to share, it's like a shared resource. So I think that's why a more naive average-based approach is kind of enough. Yeah, I don't think we would ever be designing it such that we say, yeah, this is going to go from 49.9 Mbps to 50.1 Mbps, and that's why we can't make this change. I don't think that's the intent of the limit, at least.
Right. And I think sort of using numbers, there was a suggestion to sort of look at the network and see what people are doing, or like take a subset of the network. And this is sort of a bit harder. And we're not actually sure that this is like a foolproof way, because what if you take a subset of the network that is not representative of the whole network? Yeah, I mean, if you just take everyone who's on AWS, you'll just get larger numbers than if you take everyone who's in a particular country or something like this. So yeah, this is why I think it's a reasonable compromise, especially for local block building.
That makes a lot of sense. And at the end of the day, it is recommendations. I think it would be a good idea to keep it generic and keep some headroom, as Parithosh mentioned. And thank you, Toni, for explaining the difference between like local block builder and how people using MEV Boost get benefited in like block building there. So thank you for that. I have a related question while we are talking about this numbers. It may be with respect to capacity consideration. It was mentioned in the overview that currently it is 4 terabyte and it may run with 2 terabyte. It is possible when 4 4s are there, we can get the space size smaller. We can use that, but it's not there yet. And that's why the 4 terabyte is being recommended. So instead of giving a hard number, what do you guys think about having what you call is like a range of numbers there? Like, do you think that may encourage more users to join and participate, considering hardware costs are generally a key factor for participation and node running there?
Yeah, I think that gets into the discussion of then minimal versus recommended. Because if I say 2 to 4 terabyte, then that sort of implies that 2 terabyte is the minimum requirement versus recommended is probably around 4 terabyte. And I think there were enough trapdoors in this discussion to begin with that I think we didn't want to open more trapdoors. But also just for context, right? I have a node at home. That node currently takes 1.4 terabytes. I have a 2 terabyte hard drive. If we don't ship 4.4s before that, I would have to upgrade. So it would be already prudent to suggest the 4 terabyte upgrade, considering this is a forward-looking document rather than a historic one. I'm not sure if there were any other considerations I would cover.
Yeah, I'd be super up for adding more nuances with the full node part, just because I personally think full nodes are sort of the most important sort of node types in the document. So that's sort of saying like for full nodes, you can do 2 terabytes, but here's why. We did sort of say some of that in the rationale part, but for validators, I would be up for just putting like these concrete numbers just because of the 32 ETH stipend that you sort of need to pay anyways for hardware.
Cool. And I would also like to get into the part of selection of clients. Sometimes we have noticed that the selection of clients are also with respect to the hardware availability. So would you say if there are any client specific optimization that perhaps a user can reduce to consider this hardware requirement for certain node types?
Maybe I can add with that. So as already mentioned, the max blobs feature is maybe something that people with low bandwidth want to look out for if they want to continue doing local block building. Then, of course, differences in the node themselves, right? For example, I run a lot of Ref or Aragon nodes because I need archive nodes that are not super big on disk. I think many different nodes are optimized for different things. So every user should find his perfect node combination. And then, of course, getting away from majority nodes, supporting the smaller nodes. I would say this is basically how I would approach that problem.
Very well. And moving forward, I have a question with respect to a benefit or maybe the use case. Whenever we are documenting a proposal, we would want to consider some basic use case of that proposal. Obviously, here it is a lot of use case because we are providing specification, but it was also mentioned during the overview that it is kind of a document which can be linked to many other EIPs. So I'm curious to understand as of date, maybe Pari or Toni, you can also answer that because you guys have championed Proposal 7691 and 7623. As of date, if this proposal is under required section of any proposal, do you think it can be either mentioned or considered as required proposal for any proposal either today or in future?
Yeah, I think it could be. I think I would go back to the example of the worker transition, right? Or whatever transition we choose. I can imagine if we're deciding the specifications for how such a transition needs to look like, we would need a definition of what is a supported node, in which case this could be a required proposal. However, I don't know one that might need it in this year or maybe in the next year. So potentially it's something for future folks to decide. And I mean, Kev's also a bit deeper in the ZK and proving world, so maybe he also has some examples on where it's useful for that.
Yeah, I guess we're sort of on the research/benchmarking side for some of the ZK stuff, and moving up from 4 cores to 8 cores has really sort of helped us, given that some of the research is going to take at least 5 years to reach fruition. On the ZK VM or ZK EVM side, we probably need another node type called a prover. I decided not to add it in because that would probably open up another kind of worms, given the prover needs GPU support, etc. So yeah, that's where we are currently with the ZK stuff.
Glad you decided not to include that. The smaller the proposal is, better for us, better for people who are reviewing and trying to move into the finalization stage. By the way, the reason I mentioned this, like the reason I wanted to understand, like if this proposal can be used as a required section, is because that will give us this clarity whether we should keep it as living or as finalized stage. I understand the preference here is to keep it as living and keep it updating as we go because we may be expecting, obviously we will be expecting some changes in specs in near future. However, if this will be considered as a proposal that can be under required section, generally speaking, the dependent proposal may not move forward unless this proposal has higher status. So it is a good idea to keep it into general track, move it towards final rather than keeping it towards living. That's number one argument. And number two argument is, as on date, this requirements are good to run node with whatever is going on Ethereum mainnet. When the scenario changes, we may come up with a different proposal. It can be considered as, interface kind of proposal, like ETH versions that we keep on adding. This like proposed by Get team every time we are pumping the version and we are having a new proposal. This helps us to provide a generic specification at one point of time in Ethereum history. For example, if we are going to tie it with the Pectra upgrade, if we think that this specification is good with the Pectra upgrade, we should perhaps move the proposal along with the Pectra upgrade. I mean, this is what I think, and I'm sure there are more discussion ongoing in the ecosystem, and we would be in a position to decide how we take it forward. But yeah, would love to hear your thought on that. Would you be okay moving forward with the normal track and move it towards the final status?
I think there was someone who was against sort of calling it required, just because technically these aren't strict requirements. So I guess I need to think a bit more about it.
Yeah, maybe just one problem I could see with that approach would be that we would have a new hardware requirements EIP every fork, and this would kind of be very time consuming. Of course, now we have to update that informational EIP too, but yeah, maybe having it really shipped as a standard EIP, yeah, would maybe cause some confusion, especially if the requirements change. And now in the informal EIP, we just have one place that is always supposed to be up to date.
I understand the concern there, and whatever I shared before is just my general opinion based on the experience that I have seen here with the proposals. Those are being proposed to become a standard. I generally think that it would be a good idea to move the proposal to a standard, and it can be recorded as a part of Meta EIP for that particular upgrade. Yeah, I would recommend to maybe talk more about this in order to push this proposal towards the review status, to last call, or wherever you see it going fit. I would like to continue this discussion a little bit more towards your general experience as an EIP author. To me, it seems inevitable for a client developer to eventually become an EIP author or maybe a reviewer. And I assume this is your first EIP. Correct me if I'm wrong. But as a new EIP author, how has been your journey?
I guess this is the first EIP I've written myself. I believe I've been co-authored on other EIPs. The journey was quite straightforward. There wasn't really much. I think the hard part was just basically getting agreement on the EIP itself, not really pushing stuff through. I went to, I think it was the EIP editing hours, which were pretty useful in just figuring out, is there anything missing from the EIP, and getting help from Gajendra, Sam, you, and all the others in there. So I think it was pretty smooth.
Well, thank you so much for that feedback. I personally believe that office hours are going to be helpful for new and existing authors to let them know what is required as next step, because we have seen many more EIPs going stagnant, and we don't want that. We want that authors should be around, and we are there to support. So I'm assuming that you may have received a decent amount of support that was needed in order to pursue this proposal. But in future, or even with the experience, if you may have any recommendation that may help you move this proposal even better with the help of EIP editing or reviewing team, please feel free to provide us some feedback on that. All right, with that, I am getting towards the close of the last set of questions that I have. How long do you expect these specs to remain valid? We did discuss about like it may change every year, it may change with every upgrade, but as we also noticed that these recommendations are not for just today. We are also giving room for near future. We may see some upgrades coming in future. Do you think it would be good for next couple of years or maybe more?
My personal opinion is that the full node specs should be sort of down only. The local builder specs probably up only. And the prover specs also up only. So for full nodes, I hope that you don't need to change anything. Yeah, I hope you can be able to run a full node on like your MacBook, for example.
Also, there are upgrades that kind of follow that trend, right? With PEERDAS, if you have a full node, it should either keep your bandwidth usage the same or reduce it. If you have a validator, one validator, it should be roughly the same as what it is now. If you have a ton of validators, then your bandwidth usage should go up. So that's also moving this concept of, yeah, if you have something like 8 million staked, chances are you can afford a gigabit connection. But if you have 100,000 staked, maybe you can only afford a 50 Mbps connection. If you have a full node, you shouldn't be even able to afford, it should be very cheap and easy to run a node. So I think the trend is also exactly like what Kev said. Some numbers go down, some numbers go up.
But we are relatively stable for quite some time.
Yep. I mean, literally 6-year-old machine, and I want to see how many more years I can get out of it.
And we wouldn't doubt that, Parithosh. You are our testing team engineer. We would definitely rely on whatever you are suggesting is good right here. Anyway, that brings us to my next question, like what is the next step for this proposal? From the process point of view, Kev, I can recommend that this proposal is currently in draft, so it has to go on review status. It is not required to be there for any limited amount of days or number of period, but for last call, there is a requirement of 14 days if we keep it informational only. So keeping that in mind, how soon do you think that we can move this proposal to review? Do you see any planned discussions or revisions before moving this proposal towards final status?
I don't know of any planned sort of revisions. I do know that there's this extra question which doesn't block the EIP on sort of how do we determine the cost of the hardware that people should be buying, at least for validators. Like, should it be 6 months? Should it be like 10% of however much you pay? This isn't blocking per se on this document. In terms of next steps, I thought that once we merged it, it was kind of done, if I'm very honest. Yeah, I'm not sure.
No, we would want you to be a little bit more around with us. So the general process is you can make a simple PR to move it to the review status, keep it for a week or two, then make another PR to move it to the last call. And whenever you make the last call PR, you have to add 14 days from the date you are making PR. That's when we can move it to final status. So please do not just leave it as is, because if you do, then it will be moved towards stagnancy. After 6 months, the bot will kick it out of the normal process and it will be marked as a stagnant EIP. May not be as useful as we are hoping it to be. Please feel free to ping us whenever you're making a PR. Please tag it on the office hour agenda item. We would love to review it and merge it so it can move sooner.
Okay, that makes sense. I think we can probably bring it up in ACD as to whether we should do this live status versus finalizing, and then I can push another PR to do whatever we say.
In either case, it has to go under review. So even if we are not moving towards final, moving towards living status, the next stage for this particular proposal is review. So sooner you make the proposal to review status is good. We can still make the decision of moving it into living and final at that point.
Okay, sounds good. Yeah.
Very well. We are heading towards the end of this conversation. Would you have any thoughts or suggestions for Ethereum community regarding this proposal? Any call to action you would like to share with this platform?
I could share the same call to action that I think I already shared in the blob throughput increase episode, namely that the Xatu database of the EIP-PanEIP people is still open to receive data from community members. So it would be very cool to have many community members contributing their data, so the data of their own nodes directly to the Xatu database, which will then in turn help us to have a more complete picture of the whole situation and analyze things around reorgs, around missed attestations, and everything that comes with increasing limits way better. So this is mainly my own wish here.
We also now have a dAppNode package. So if you have dAppNode, you can more easily install, the tool is called Contributor. So you can more easily install Contributor. The ETH-PandaOps blog has a blog post on how you can apply. It's still permission to apply, and we have to give you an API key so you can send the data. And as of today, I think we are at 70 individuals who are sending us data, which is not that bad. That's roughly, I think, around like 0.5% of the network, or a bit lower than 0.5% of the network that is actually actively sending us information, which is great. I think we want to try and get this to maybe 1-2% of the network actively sending us information, so we have a good sampling of how things are.
Very well. Thank you for sharing that. Generally speaking, we always encourage community to participate in active discussion, and we do have Fellowship of Ethereum Magician page where they can add their thoughts and their comments with respect to this specific EIP. And I would like to also respond to one of the comment that Kev mentioned earlier. It was about like there is one open but unrelated comment like about the cost of the hardware. So just for information, The authors may note that whatever comment they receive on Fellowship of Ethereum Magician, if that is not directly related with specs, it's not mandatory to close before the proposal can be moved forward. So you are free to accept or reject that comment/suggestion, but it is always a good place to have all these pro and against comments at one place, and that's why we highly recommend people to participate and leave their comment at Fellowship of Ethereum Magician. So I'm looking forward to collect some more feedbacks and thoughts on there. And before we wrap up today's session, I want to get to the most interesting side of this conversation, which is called rapid fire round. I love this part. I know Pari and Toni has answered some of the questions before, so we have collected some new questions for you. But let's start with Kev. Kev, just to give you some overview of how this round goes, we try to ask you some question which can be responded either in one word or one sentence. We'll try to keep it in less than 1 minute. So are you ready?
Oh, yeah.
Cool. For you, most exciting upgrade so far?
Probably Pectra, because there's been quite a few bugs that have been interesting.
Cool. Ideal validator setup to you?
Currently, because I have a Minas forum, I'd say the Minas forum that I have.
More crucial, is it CPU or the RAM?
I think RAM at the moment, just because state is one of the biggest bottlenecks currently, or it will be as well.
Future of node hardware, what would you consider as ideal configuration?
I think we're going to have a lot more types of nodes in the network in the future. And basically, I think the network's going to start leveraging asymmetry, which is what you see between full nodes and validators now.
That makes sense. Okay, the final one here. One word advice for node operators.
Please try to send your data to the EIP team.
Thank you so much. And I'm glad I kept it with sentence as well, because yes, of course, some of the questions could not have been answered in just one word. Very well. My next set of questions are for Parithosh. So Parithosh, easy to test client, consensus or execution?
I actually like consensus, the specification, which is nice.
Easy deployment, is it on mainnet or testnet?
Testnets.
Fastest way to debug a network issue?
Get everyone in one room and start looking at logs.
Hardest bug you have fixed?
Ooh, I don't have an immediate answer. No clue.
Most used command in your terminal?
It's probably docker ps-a to find what containers are running.
Favorite Ethereum testnet?
I really like the merge shadow fork, the first one.
Well, thank you so much. It was real quick. I was hoping that you can say a little bit more about Hoodie, but that's all right.
That's true, actually. Hoodie is a new network that we have, and it's the first network that I actually got to name, because every other testnet has been named ahead of time. So the naming convention is quite straightforward. A testnet has to be named after a metro station, doesn't matter where in the world. It has to be hard to pronounce, and it has to be difficult to spell. So most people so far have spelled Hoodie with an E in the end, so it succeeds there. Hoodie is also, I think the usual way you pronounce it is more like hoodie, like the one you wear, but there's no E at the end. So you also pronounce it a bit different. Find a Kannada speaker if you want to know the actual pronunciation. And it's a metro station in Bangalore.
That's great. Thank you for sharing. And I believe you have also tweeted about it. That tweet contains quite a lot of information.
And there's some lore. We also in the office in the EF have all the city maps where all the testnets are named with a pin as to where the testnet is. So Robston, Rinkeby, Gurley. So Gurley is after Görlitz Bahnhof, and there's a bunch of them. So all of them are testnets, all of them hard to name, hard to spell, and so on. And to Gary's point, what is life without whimsy? So we create arbitrary rules for testnets.
That was my question as well. Thank you for answering that. Moving on to Toni. So Toni, the first question here is biggest bottleneck in scaling according to you?
Definitely bandwidth, I would say.
Most underrated hardware component?
Storage.
One word to describe writing an EIP?
I would say being precise.
Favorite open source project?
Ethereum.
What would you call as one essential dev tool?
That's a good question. There are many dApp tools. Let's say, because I've always been a fan of one specific tool that no dApp developer ever uses in production, but I would say Remix.
One word for Ethereum's future.
Different entities with different skills.
Very well done. Thank you so much, Toni. And I'm really glad that you did not describe writing an EIP as complicated. The best word was precise. Because I have heard from many developers, like they are good in providing specification, but they don't want to keep up with writing, documenting, and like going through the process. So if you come up with precise EIPs, precise proposals, I don't find it's going to be complicated. We are around to support you with the process part of it. Although Tim Bako has done an incredible job in explaining the process for core developers, especially, and we are changing some processes to make it easier for people to stay updated with EIPs which are being considered for network upgrade. And that's a wrap for today's episode. We had a great discussion on EIP-7870 hardware and bandwidth recommendation and its role as an informational EIP. Huge thanks to Kev, Parithosh, and Toni for breaking it all down and highlighting the importance of this well-defined specification for network efficiency and hopefully decentralization. Ethereum is constantly evolving, and conversation like this on PEEPanEIP will help drive meaningful progress. If you found this episode insightful, be sure to check out the proposal, share your feedback, and contribute to shaping Ethereum's future. Special thanks to my colleagues at ECH, Akash and Valeen for their support in putting this episode together. If you enjoyed it, don't forget to subscribe and share. Until next time, keep exploring, keep building, and keep perfecting Ethereum. This is Pooja Ranjan signing off.